This is Wael Bashuri, math and physics teacher. In this video, I'm going to solve an online quiz, physics grade 9, week 5 AMS. So let's start directly. The refraction of light is being investigated using a rectangular perspex block as shown below. Which of the following observations are true in this investigation? Select all, apply. Clearly you have here an incident ray, and this is angle of incidence I, and this is angle of refraction R. So what you have to do here, if you read the options, at point A, the angle of incidence is equal to the angle of refraction. This is never correct because the angle of incidence equal angle of reflection. Emergent ray is perpendicular. No, emergent ray here, this one emergent, this is incident, they are parallel. They are not perpendicular to each other. So this is again wrong. At point B, the refracted ray is bent towards the normal. At point B, it bends away from the normal. So this is away from the normal, not towards the normal. Towards the normal would be like this. Away from the normal would be like this. So it's away from the normal. So you have to choose away from the normal. At point B, refractive ray is bent towards. This is incorrect. Emergent ray is parallel. This is correct. Then at point A, the refracted ray is bent towards the normal. It's incorrect. At point A, the refracted ray is bent towards the normal. Yes, this is correct because here at A, if you can see, it bends towards the normal. Question number 2. Okay, this is easy. Let's leave it. Question number 3. Also, this is easy. A beam of light strikes the surface of separation of two media. What are the conditions needed for light to undergo total internal reflection? Total internal reflection, the angle of incidence should be greater than critical angle. This is correct. And the light should be traveling to an optically less dense medium. Should be traveling to an optically less dense. This is correct. Which statements are true about prism periscope? This is easy. Let's leave it to you. Here, a ray of light passing through water strikes normally the plane face of separation with air. Which of the following statements are true? Okay, any ray that strikes normally the surface of separation between any two media will continue grazing the surface of separation? No. The angle of refraction is independent of the media. This is correct. The value of the angle of incidence is 0. This is correct. The angle of refraction depends only on the speed of light as strikes. This is incorrect. The angle of refraction is 0. Number 6 now. How does the speed of light change as the index of refraction increases? Speed of light decreases. For example, speed of light in diamond is less than speed of light in water because diamond has greater refractive index. Question 7. Select the optically denser medium. The greatest index is the denser medium. So glass crown. Greatest refractive index. Number 8. Match each term to its definition. Medium of refraction, the space where light travels after it strikes. So that's the medium. Refracted ray, the path followed by an incident ray after entering the new medium. Angle of refraction is the angle that a refracted ray makes with normal at the point of incidence. Number 9 now. Select the equation that best describes the second law of refraction. Second law, sine I over sine R equal constant. So this is the second law of refraction. Number 10. The angle of refraction to the nearest degree. Okay, so here you have to calculate You can use Snell's law to calculate. Let us see. A ray of light is incident in glass on a glass water boundary with an angle of incidence equal to 40, given in the diagram shown below. It is given that the refractive index of glass is 1.5. So here it comes from glass to water. What's going to happen? We don't know here whether it refracts away or towards the normal. We have to calculate. So N1 sine I equals N2 sine R. N1 is refractive index of glass because it comes from glass. 1.5 times sine 40, that's the incidence angle of incidence. N2, it goes to water, which is 1.3 times sine R, we don't know R. Now we divide both sides by 1.3, 1.3. Now we have sine R is equal to this amount. This amount on the calculator, you write it here. Then you do R equal shift sine inverse. And then you get the answer. Super easy. Use your calculator to find the answer. Number 11. The diagram below shows a ray of light incident from air striking the surface of separation, air, water, and refracting inside the water tank. The ray reflects at the bottom of the tank and emerges out of the water, making an angle alpha with the normal. What is the angle alpha? Since here the angle of refraction is 45, here the angle of incidence is 45, this means alpha will be 40. Number 12. Select the diagram that best represents the graph comparing the sine of the angle of incidence in the transparent medium to the sine of angle of refraction in the adjacent transparent medium. So here the sine I over sine R must be constant, so you have to choose this option because the slope is the refractive index. The slope here is constant. Number 13. Where does internal reflection take place? At the interface between two medium, in any opaque medium, in any transparent medium, at the boundary with air only, at the interface between two mediums. Number 14. Fill in the blank using the correct term from the box below. Drag and drop. Total internal reflection may only occur when light passes from a medium of more dense, from a medium to a more dense medium. So it comes here, for example, when we say it comes from water to air, here we can have total internal reflection like this. So it comes from more dense to less dense. So it must go to a less dense medium. So here, less dense. Number 15. The angle of incidence that provides an angle of refraction 90 is called critical angle. Number 16. A ray of light is traveling in water. Before it strikes the plane surface of an ice cube, the critical angle at the plane surface of water ice to the nearest degree is. So here I have to calculate the critical angle, which is the angle between the incident ray and the normal, which means the angle of incidence. So again, Snell's law, you can use it here. So N1 sine I equal N2 sine R. N1 is water, given to us here, 1.33. So 1.33 times sine critical angle, we don't know it, equal N2, which is ice cube, 1.31 times sine R. Now you divide both sides by 1.31, cancel this and this, get this on the 1.33 on both sides. Let's repeat. So here you have to divide both sides by 1.33 to cancel these. Now sine C would be on the calculator this, and then you do C equals sine inverse this amount. Then you write the answer nearest degree. Number 17. A ray of light travels through water at speed 2.25 times 10 to the power of 8 meter per second. What is the index of refraction of water? Index of refraction, we know from the formula, sine I over sine R equal index of refraction. But here we don't have neither I nor R. So let's use another one. N is equal to speed of light in vacuum over speed of light in medium. So refractive index would be, in this case, 3 times 10 to the power of 8, that's speed of light in vacuum, over speed of light in medium, 2.25 times 10 to the power of 8. Use your calculator to pick the answer. Question 18. The laws of refraction are used to study the transfer of light between two media. The first law of refraction states that the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. What is the plane called? Now the plane is called plane of refraction. What does the second law of refraction state about the ratio of sine, the angle of incidence, to that of angle of refraction? Here it is constant. 19. A ray of light passing through air strikes the plane face of water, refractive index 1.33, at an angle of incidence 53. What is the angle between refracted ray and the normal? Again, here we use Snell's law. N1 sine I equal N2 sine R. N1 here is air, it's coming from air, so 1 times sine 53 is equal to N2, which is 1.33, times sine theta R, or R. We divide both sides by 1.33, and then we do shift sign. Number 20 now. An incident ray of light strikes the boundary of separation between two media at the critical angle theta and undergoes refraction. What is the angle that a refracted ray makes with the normal? Okay, an incident ray of light strikes the boundary of separation between two media at critical angle. It must go 90 degrees. Next one. The diagram below represents a glass slab and 3 incident parallel rays. Select the diagram that represents the correct path of the rays as they propagate inside the slab. So here you have to select first option because the emergent rays are parallel to the incident rays. Number 22. Here you have an ray of light coming perpendicular to the semicircular glass block. At M, the ray is incident normal to the surface, thus it will continue undeviated. At N, the ray strikes at an angle, thus will refract away from the normal. Okay. Part B now. The ray of light strikes the point N at an angle of 42. Then the emergent ray grazes the surface. 42 is called the, here you have to write critical angle. Critical angle, because it grazes at 90 degrees. Grazes means 90 degrees to the normal. The value of refractive index of the glass block to two decimal places. Refractive index is equal to 1 over sine critical angle. So just divide the critical angle you get here, put it here, plug it in this equation, you find refractive index. I will continue the rest of the questions in a separate video. Thank you very much indeed.